morning, all. Am I audible?
Yes, sir.
Last problem we are discussing is a rope is on the inclined plane having angles alpha and beta. That one, no? Am I written it? Hello?
Yes, sir.
Last class, what we have discussed, I am asking, what are you talking, right? Early morning sleeping. Huh?
Sir, a homogeneous flexible rope rests on the
That's
wet
right.
center.
Okay, correct. Now, from all these discussions we have, this is what we learn now. Clear?
Yes, sir.
Understood, Dave?
Yes, sir.
Clear?
Yes.
See, suppose this is the earth, this is the particle. Now, this is the force. Actually, this force is nothing but upon manipulations, you will get this mg. Okay.
Yes, sir.
Since g equals, similarly, whenever a body is there on a surface, So normal reaction, action, reaction. Understood this?
Understood, sir.
Like that even tension. The body is here. Then you can see that on this person, understood this? They always form action-reaction pair. Clear? So,
Clear, sir.
understood this?
Yes, sir.
Shall I turn the page?
One
Always. Always.
Hello? Shall I turn the page?
yes, sir.
Now let us solve some problems based on this. This is one cart. From this cart, we are hanging a mass smaller. Okay, so we can say that if the trolley accelerates horizontally, understood the question?
Yes, sir.
Yes, sir.
Try. See, first choose the observer. See, from ground. Understood this?
Yes,
One
sir.
is a ground observer. Ground observer means he is non-accelerating now.
Yes, sir. Non-accelerate.
Now, what does this fellow see? He sees that this point is there now. He sees, will they see the bob? First, what will move?
Trolley.
Trolley will move. Due to this P point will first move. The bob will not move immediately. Now the bob will be like this. Understood this?
Yes,
Followed?
sir.
Yes,
Follow.
sir.
The situation is, this is what he sees. He'll first see that point of suspension moves forward. When point of suspension moves, bob will be staying there only, original position. It won't go anywhere. This is the acceleration. Agreed? Followed?
Agree, sir. Follow.
So acceleration of bob with respect to observer O1 is acceleration of bob with respect to trolley plus acceleration of trolley with respect to O1. Bob is resting in the trolley. This is A. Do you agree with this?
Yes, sir.
Agree, sir.
Any doubt is there? Right. Because the bob will be in equilibrium. Okay. Any doubt is there till here?
No, sir. Clear.
Right.
Sir, one
Now,
doubt, sir. Sir, both will be in equilibrium means what, sir?
equilibrium means it is having same acceleration with respect to the trolley. Therefore, acceleration of bob with respect to trolley will be zero.
Okay, sir. Yes.
Understood it?
Yes, sir. Understood.
Clear. That means acceleration of bob with respect to trolley is zero. That is the meaning. Understood this?
Understood,
The
sir.
doubt is that till here. Right.
No, sir.
Then
No,
he
sir.
shows this, then that fellow shows the forces. There's a tension like this, mg like this. Then what I told, resolve the forces, along the direction of accelerations and perpendicular to the direction of acceleration. Okay. So now we shall resolve this. This is also theta. So what will be this?
T cos theta.
What is this?
T sin theta.
Great. Now you can see
Yes,
he
sir.
writes the equations. Sigma fx m ax. That means here T sin theta is the only force. Mass into acceleration of Bob with respect to observer O. This is what we took now. Okay, in the x direction. There is nothing but MA. No? We got that or no? Clear? No,
Yes,
we need not take pseudo forces. Reason is he is not having any acceleration. So here T plus minus mg, there is no acceleration of Bob with
sir.
respect
T
to
cos theta.
which one?
T cos theta plus minus mg.
T cos theta. So T cos theta minus mg. There is no acceleration because you can see it is only along I cap or na. So this is 0. So what is that you got? T cos theta equals mg. Therefore, we have two equations. What are those? T sin theta equals ma. T cos theta equals mg. If you divide one by the other so the tension can be eliminated, you get sin by cos
A is
as
equals to
A by
A by
G.
tan.
So A equals G tan theta. Understood this?
Understood, sir.
Shall I turn this?
One minute, sir. 1 minute. Completed,
Completed?
sir. Yes, sir.
Yes,
Now, let us solve this with respect to the accelerating observer. So this is the cart, this is a bob like this. This is the observer O2. Observer means some point. Okay. Now let us solve with respect to okay. When the acceleration of O2 with respect to ground is nothing but acceleration of O2 with respect to O1, no? Great. This is nothing
Yes,
but
sir.
acceleration of cart with respect to O1. There is nothing but acceleration AI cap. So this acceleration with respect to ground we could find. Understood this or not? Now let us see what are the forces that fellow will act. What does that see? He sees that this Bob is there. He will observe there is a pseudo force here now. Therefore, they agree or not?
Agree, sir.
The Bob comes here. What is the pseudo force, man? Mass of body into acceleration of observer with respect to ground taken in
Yes.
opposite direction. That's the reason why we are taken like this. So this is nothing but m into a. Do you agree with this or not?
Yes, sir.
Any doubt is there?
No, sir.
No, sometimes pseudo forces help us to solve easily. Sometimes they're not required. So I'm just explaining how to solve by pseudo force and without pseudo force. So this is some theta. This is theta. Now we can see what is the acceleration of Bob with respect to O2. 0, no? Because acceleration of Bob with respect to ground minus acceleration of O2 with respect to ground. Both are in the same direction. Do you agree with this or not?
Yes, sir. Agree, sir.
Great.
Agreed, sir.
So now this fellow has no acceleration. So what he says is this is t cos theta. What is this? T sin theta. Now he writes the equation max. So he writes t sin theta plus minus ma is mass into acceleration of Bob with respect to O2 in the x direction, which is 0. So therefore he says t sin theta equals ma. Do you agree with this? Clear enough?
Yes, sir.
Again he writes sigma fi equals ma t cos theta plus minus mg m into acceleration of Bob with respect to O2 in the y direction. This is 0. T cos theta equals mg. So you are having T sin theta equals ma, T cos theta equals mg. So if you divide one by the other, so A equals what? G tan theta. Same thing you got as before or not?
Yes, sir.
Any doubts are there in this?
No, sir.
So that means a
No, sir.
problem can be solved by considering pseudo forces, which is in the accelerating frame, or without pseudo forces. So it depends upon the situation. It all depends upon the situation, how you manage. That means the requirement, only thing is it's not necessary to conjure pseudo force always, but sometimes it will be easier for you. Shall I turn this?
1 minute, sir.
ప్రాణాయామం చేస్తున్నాను.
Hmm.
ప్రాణాయామం చేస్తున్నాను.
Shall I turn the page?
Yes, sir.
Yes.
Let us see another question. So this is a rod. There is one bead on this. Okay. This is alpha. See, this rod moves. Okay. You're supposed to find Any idea?
No, sir.
Sir, by applying pseudo forces, finding.
No, first you try with respect to ground. Both methods we should try, man. All our efforts is to master the techniques available, not to solve the problem. So, for example, we have an observer on the ground. So, we'll write with respect to so here what does that fellow show? He is asking relative to the rod, no? He will first say let acceleration of bead some AR So here I am taking this acceleration as AR. Okay. So this has two components. This is also alpha. What is this? AR cos alpha, AR sin alpha. Follow this? So
Yes.
he will try to draw the free body diagram for that. What are the forces FBD of the bead? If you draw the FBD of the bead, this is the normal reaction. This is mg. Do you agree with this? Now, because this is alpha, this is 90 minus alpha. Do you agree with this? Hello? So therefore,
Yes, sir.
it has resolve the forces in the direction of axis. N cos 90 minus alpha. That is nothing but n sin alpha. For this. And this is, of course, we don't require this. And he says that this is having an acceleration of AR cos alpha understood this.
Understood, sir.
Now, who is the observer? We have to find acceleration of Bob with respect to over. Do you agree with this?
Agree, sir.
Plus rod with respect to O1 is in which direction it is moving? A minus I. That means he has A plus AR cos alpha understood till here.
Yes, sir.
All this, it should be on the fingertips, resolutions, everything.
Sir,
Okay.
how is the normal reaction in that direction?
Normal reaction means perpendicular to the body. Okay. This is surface in contact. This is a bob. The bob is in contact with the rod. So this is the tangent to the contact. So this should be the normal reaction, no? The name itself is indicating that it is perpendicular, no?
Yes, sir.
Eh? Bob will be exerting the rod will be exerting a force on the bob in that manner, you know.
Yes,
What
sir.
is the
Yes.
normal force? By the rod means the force should be normal to the rod now. Normal
Yes, sir.
force exerted by the rod. What is the meaning of that? The force should be perpendicular to the rod or not? Understood this?
Yes, sir.
Now he writes the equations. Sigma fx equals, he says that n sin alpha in this direction is mass into acceleration of bob with respect to O1 in which direction? X direction. This is nothing but A plus AR cos alpha is n sin alpha. Also again he writes sigma Fy MAY. What is sigma Fy? N cos alpha plus minus mg is m into acceleration of bob with respect to O1 in the y direction. N cos alpha minus mg is m into you have AR sin alpha. Agreed. So what is n cos alpha? Finally you got m
M
AR
into G plus AR sin alpha.
mg. Do you agree till here? Is it clear? Now you can see you are having two equations. What are those? N sin alpha equals m into A plus AR cos alpha. N cos alpha equals m into G plus AR sin alpha. Divide one by the other. What you will get here? Tan alpha do you agree with this? Now find out AR. Cross multiply and find out AR. Understood the method? Any doubt? Shall I do? This one, cross multiplication.
Sir, A minus G tan alpha by cos 2 alpha into cos alpha.
Cos 2 alpha. Do it carefully. The tan you can write sin by cos. Finally, he gave this. See?
Yes, sir. G sin alpha minus A cos alpha by cos 2 alpha.
Correct or not?
Yes, sir.
Got the same thing? Shall I turn that? Not getting this.
Sir, we are getting G sin alpha minus A cos alpha by sin square alpha minus cos square alpha.
Sin square plus cos square is how much? 1 only, no?
Yes, sir, but sin square minus cos square.
Check up some sign you done, some mistake.
Sir, we should take m into minus a plus ar cos alpha, no, because it is minus I cap.
Which one? First one, huh?
In sigma fx, sir.
Correct or no? I'm taking this force as positive, no? Then here you have to take minus I. That minus I, this minus I will be cancelled, no?
Yes, sir, minus minus
Yes, sir.
cancel.
Okay, here the mistake is done. Acceleration is downwards, no? So this is the equation. Mg minus. That is the problem we are having. Understood this? Now you will get, I think. See, here the mistake is Mg, that is positive, no? Acceleration is downwards, no? Agreed on it?
Yes, sir.
Now you will get, I think. See?
Sir, we should get a minus sign either to AR cos alpha or AR sin alpha.
Hmm? What and when? I didn't get you.
Sir, with by this also we won't get this, sir.
Wait. Agreed. Already you got tan sin alpha is how much? divide one by the other. Okay, now cross multiply. Is it correct now? See, you must get that.
Yes, sir. Now we will get.
See, one small sign, if you take mistake, whole problem will go wrong. That's why you should be cautious while doing physics. You should get this, see.
Got, sir. Answer.
Finish it, got there? Hello.
Yes, sir. Got. B sin alpha minus A.
Yeah. Shall I turn this?
Yes, sir.
Yes, sir.
Now, solve this problem with respect to the rod. This is the rod now. This is alpha. Now this rod is having an acceleration like this now. Now we have to do with respect to an observer. Okay. So let us take a fellow on the rod. So for example, one fellow is there here, something. So with respect to whom O2 is having accelerating. Now see, we have taken the acceleration of what? Bead with respect to rod. That is O2. Okay. Along the rod and downwards. Do you agree with this? This is what we have taken.
Yes,
So
sir.
the thing we have taken is this fellow we have taken here. Now that fellow wants to draw the free body diagram. What he says is, this is the normal reaction and this is mg. So he'll write the equations along the rod. Can you tell along the rod what you have? Net force. What is the only force you have along the
And
rod?
also
So
N
there is
sin
another force according to him. What is that force?
pseudo force.
Pseudo
Pseudo
force
force.
will be in this direction now. So he will write this fellow will write the forces. Sigma F equals MA of observer or bob or bead with respect to O2. That fellow will write like this. Along the what you have mg cos alpha, do you agree? Plus minus ma sin alpha, opposite, no? M into AR. Do you agree with this equation? This is mg cos alpha, sorry, cos 90 minus. So this is 90 minus alpha, no?
Yes,
This
sir.
is 90, no? So this is MA cos alpha, no? So what is that you have? So you have
Sir, MA cos alpha, no? Along the rod.
previously you got the same thing, see?
Yes, sir.
Now this is easier now compared to that.
Yes, sir.
So that's the reason why I'm saying it depends upon the situation. You can consider pseudo force or you need not consider pseudo force. Understood what I mean to say?
Yes, sir.
So return this.
Yes, sir.
Shall I turn this?
Yes, sir.
Now let us solve another problem. That the Atwood machine having two masses suspended to it. This is M1, this is M2. This is A naught. Find acceleration of with respect to elevator. Okay. A naught is acceleration of elevator with respect to ground. Do you agree with this? Now, this problem can also be done like this. First one, we are trying to solve with respect to O1. Okay, so let us observe that here A naught so this is nothing but acceleration of pulley with respect to ground. Do you agree with this? Any doubt is that till here? Any doubt is there? Pulley is fixed to the elevator now. Hello?
Yes, sir.
Speak something, man. No, don't understand now. You're understanding or not? The pulley is fixed to the elevator. Therefore, acceleration of pulley with respect to ground is same as acceleration of elevator with respect to ground. That is A naught upward. Okay, this is the situation. Now let us see. Let an assumption. A is acceleration of M2 with respect to pulley. Understood this?
Yes, sir.
Downward. Then, what is the acceleration of M1 with respect to pulley is AR upward. Do you agree with this? Clear?
Yes, sir. And
Now draw the, now we should get from this information acceleration of M1 with respect to O1 is nothing but acceleration of M1 with respect to elevator pulley plus acceleration of pulley with respect to O1. This is downwards, no? Upward, upward. This is upward. This is also upward. A naught. So you get AR plus A naught J cap. Agreed.
yes, sir.
Then similarly, because we want with respect to this, otherwise we cannot apply Newton's laws, no? M2 with respect to O1, acceleration of M2 with respect to pulley plus pulley with respect to O1. This is nothing but M2 with respect to this, what you have taken, AR minus J, and P is A naught J. So you have A naught minus AR. In which direction? Or if you want, you take like this. A naught
AR minus A naught minus.
J cap. Do you agree with this?
Yes, sir.
Now we will draw the FBD of M1. So for M1 you have M1G. This is nothing but tension. This is the acceleration with respect to O1. How much you got here? AR plus A naught. So we will write the equation as M1 into AR plus A naught. Agreed. Similarly, you are having M2. This is M2G. This is the tension, and that fellow is having an acceleration downward as AR minus A naught. So we write the equation M2G minus T equals M2 into AR minus A naught. This is one equation. This is the other equation. Okay, the unknowns are what? Unknowns are what? T and AR. Can't you solve two equations in two unknowns?
Yes, sir.
Any doubt is there? See, slow and steady wins the race. Drop by drop makes an ocean. Okay, so have some patience. Shall I solve these equations or can you solve?
We will solve.
See, any one small error comes in solving. Again, you have to check up the whole problem. That is the issue. Solve it carefully.
Sir, AR is equals to M2 minus M1 into G plus A naught by M1 plus M2.
Correct. You will get this, see. Got this?
Yes, sir.
Completed, sir.
Got, sir.
Finished this?
Yes, sir.
Yes.
Here, turn this.
Yes, sir.
Now, can we solve this with respect to O2? If you take here, we are having
కడుపులో ఏమన్నా బానే ఉందా?
now with respect to O2, what we have taken acceleration of M2 with respect to O2 is nothing but acceleration of M2 with respect to
With
pulley.
respect to pulley.
That is nothing but M2 with respect to elevator. Okay, this is what we got. Say AR now we have
AR
taken.
J cap. Yes, sir.
This is what we got now. Now, if you draw the free body diagrams of these masses, this is M1G, this is T, this is AR. So he writes that. And is there anything else? One extra force will be there. What is that?
Yes, sir. Pseudo.
Into acceleration of what? O2 with respect to ground. That is M1 into A0. Agreed. So he writes the following. T plus minus M1G plus minus M1 A0 is M1 AR. Do you agree with this?
Yes, sir.
Yes, sir.
The second one we have is this is T M2G into AR. Okay. Here you have, there is pseudo force in this. What is the pseudo force here? Follow this. So what is that equation you have? M2G plus M2A0 plus minus T M2AR. M2G plus M2A0. We agree with this? Minus T.
Yes, sir.
Follow this? Any doubt is there? This is the pseudo force, no? Now you are having, this is one equation, this is the other equation. Now solving that, you'll get the same thing or not? Shall I solve? Simultaneous equation, you can solve it.
Yes, sir.
Solve.
See, man, if you do 50% of the difficult questions in advance, you're an IIT. So you need to have patience. There is no other go. Okay.
Got, sir.
Got it?
Yes, sir. Got, sir.
Clear? Hello?
Yes, sir. Yes, sir. Clear.
Shall I turn this?
1 minute, sir.
So you can see sometimes ground frame is better, sometimes accelerating frame is better.
Yes, sir. Got the answer.
Any doubt? See, you'll get the same results what you got earlier. Got this?
Yes, sir.
As you can see, if A naught equals 0, then you'll get the same thing as previously. Previously you got this, remember or not? Atwood mission, previously you got this or not? Previously, if A naught is 0, you got this or not, man?
Yes, yes, yes. You got.
Sir, previously also G plus A naught.
Not previously,
got-
not the previous case. Earlier, when
Yes,
Atwood
problem.
mission, the elevator is not moving.
Yes, sir. Yes, sir.
When elevator is not moving, I am just keeping two masses. You got the same thing or not?
Correct,
I'm
sir.
saying net pulling force by M1 plus M2. Okay, clear?
Yes, sir.
Shall I turn this?
1 minute, sir. Excuse me, sir.
Tell.
Sir, I'm not understanding that part. If A naught is equals to 0.
What is there to understand? Until here you understood, no? I
Yes,
am
sir.
just giving an additional one. Previously, you have done one problem called Atwood mission. Okay, in that pulley is at rest. Okay, if that is the case, you got this relation. If you want to check up,
Yes, sir. Yes, sir.
I just used whether you are getting that or not. If the pulley is not moving, I should get A naught 0. If I substitute A naught 0, I should get the previous case now.
Yes, sir. Yes, sir.
This is how we have to connect your brain from previous to present, and then only you will have the total knowledge of engineering in your mind when you go into the field of engineering. I'm just connecting that earlier when pulley is at rest. Then what is that you got at that time? You can check out. This is AR, this is A. So we got this. That's what I'm giving. Understood this?
Yes, sir.
Shall I turn this?
Yes,
Yes.
sir.
Hello.
Yes, sir.
There's nothing to worry about this one. The only thing is that A with respect to B, all that is feeling irritated, but there is no other go. Because 2026 will be earning lakhs of rupees per month and you won't pay anybody except yourself. Now you enjoy that now. To get that into that fold, you have to do all this. There is no other way. Other things, shortcuts are only for your temporary satisfaction. M dash. Other people are studying what we can do. We have to. You can see our history also. Earlier, people used to be tribal people in the forest and all. They used to cover with the leaves their body. Now, like modern civilization, essentially dressing has totally changed. That means we have to move with society. When others are studying and doing all this, we have to study and do that. So otherwise, we'll be leftover people. Nobody bothers us. Right. So this is the case. Here the blocks. Do not slide. See, acceleration of the wedge means with respect to ground. Nothing is mentioned. It means with respect to ground. See, suppose you have a situation here. Let us take this whole system. This whole system, let us consider to have an acceleration capital A this side. This is the acceleration capital A. Okay. Okay. Then let us see, we will analyze with respect to O2. Okay. Then what are the free body diagrams of this? Let us see. This is the tension. This is the pseudo force. Do you agree?
Yes, sir.
Now this is acceleration of M with respect to O2. Acceleration of M with respect to capital M is 0, no? Given. See, they do not slide. Do you agree with this?
Yes, sir.
You have T
Yes, sir.
plus. See, I am not showing vertical forces because I don't require that. Understood this? Not that they are not acting. They are acting. If you want, you can show that. No problem. Agreed.
Yes, sir.
So there is pseudo force on this also. So here also md dash minus t. M dash is not accelerating now. Okay. Therefore,
yes.
what is t? M dash g. From these equation, what you have? What is this? M dash by m into g. Do you agree with this?
Yes, sir.
What are this?
Yes, sir.
Now we can see net force on the system acting on this is m plus m dash plus m into a. So m plus m dash plus m into what is a? M dash by m into g. So thus you got the force. Okay. That's what is asked now. One is the force, second one is the
Yes, sir.
system. And he is asking the acceleration. What
Completed.
is this?
Yes, sir.
Right. See, tomorrow I'll start something called constraints. That is much more difficult than this, but it's most important for your physics classes. Okay. So don't be absent for
Okay, sir.
tomorrow.
Yes,
Okay,
sir.
don't be
Okay,
absent
sir.
tomorrow. You'll be missing a lot. Right then. Take care then. Bye.
Thank you, sir.
Bye bye.
Thank you, sir.
Yes, sir. Bye, sir.
Bye bye bye.